I'm very happy to introduce the final speaker for today, Professor Tomas Linkevičius. Tomas is a professor at the Vilnius Gediminas University in Lithuania, but I think he's definitely best known for his zero bone loss educational program. His newest book was the #1 bestseller in dental implantology in 2020, and I bought it, and it's a thick book. I don't read many thick books because I don't have the time, and I read your book. It has really inspired me a lot. I love your thinking, your technical thinking, but also your biological thinking. So I asked Tomas, can you make a lecture and talk about some zero bone loss considerations for this novel approach with the matrix? So I'm very happy to welcome to the stage Professor Tomas Linkevičius for his TRITalk with the title Zero Bone Loss Considerations for TRI Matrix. So welcome to the stage, Tomas.
Hello, everybody. First of all, let me tell you a little story how I came here. Because when Sandro contacted me, you know, like we have something, a new implant, etc. Well, I said, okay, so what's it about? No cement, no abutments. I said, but you know, I'm doing this for 10 years. So, well, what's new? No vario base, no tie bases. Well, I said, okay, so, but you still can mill direct to implant titanium structures. But then he took out his trump card and said, but this is also for zirconia. No tie base for zirconia. So that really drew my attention and said, okay, let's look at it. And this is, here I am. We'll talk about how zero bone loss concepts and the new matrix implant can be combined. And first of all, of course, what I've been doing research and talking and discussing for past 10 years is possibility to get bone stability with different designs. So you can have implant, bone level implant, you can have tissue level implant. You can have implant level restoration, abutment level restoration, immediate restoration. Doesn't matter what kind of treatment approach you are doing, it is really possible to have no bone loss or zero bone loss concepts. I've been introduced, and yeah, I'm coming from Vilnius, Lithuania. However, the best actually way now to really get in touch with me and follow me on social media, we have now over 50,000 people following the concept. So indeed, it is, I think, a good opportunity to get in touch. Also, pandemic has changed the way we communicate. And indeed, this event shows this as well. It's a hybrid event. Majority of people are watching it online, while here I see also some colleagues sitting. That made me to bring all education online and to learn to be able to reach out for education, doesn't matter where you are. For many years, I've started my lectures by showing these two implants. So these are the same implants, same, let's say, design, same company. And one of them has bone loss and the other doesn't. And of course, we can argue till death, does this implant with some bone loss, does it really matter for longevity of the implant? However, if I put the question in the other direction, which implant you would like to have in your mouth or in your close friends, relative, children, or family mouth? Of course, then we would think that we would like to have implant without bone loss. Now, this paper is, I think, one of the most known papers in implant world, and for many years it was cited as a good reference, saying that 1.5 millimeter of bone loss after 1 year is a success. But listen, the paper was written in 1986. So we cannot agree that this is success criteria anymore. So we need to really bring it up and forget that these X-rays, all these are my cases, show stable remodeling, I would say stable surrendering of the idea that you can have bone stability. And indeed, you can have really bone stable around your implant. Now, so let's turn the page and look how matrix implant, trial implant, new design can blend into the thinking of crestal bone stability, at least from my perspective. The power of zero bone loss concepts, I think, lies, and probably also the popularity of the book, which was published 2 years ago, is that we combined both worlds together. In other words, surgery and prosthetics come as one. So it isn't, just surgical concepts or just digital and prosthetic concepts. It's one way. However, first of all, of course, we start from implant placement. So let's look, how does this really blend, in my opinion, in implant design and implant placement? Well, first of all, of course, let's look at tissue-level implant. So tissue-level implant, from my point of view, should be placed as it's designed in a tissue-level position. It means that this polished or not polished anodized surface should be left above the bone in order really to have contact with soft tissues. Of course, it is possible only when you have sufficient thickness of vertical tissues, because that is one of the pillars of zero bone loss concepts, to have sufficient soft tissue height in order to protect our implant from the bacteria. So if you have sufficient thickness and you place the implant according to the bone level, tissue level, leaving the polished part above the bone, I think it's fine. Now, what do you do if you do not have that vertical tissue thickness of 4 millimeters? One way is to augment the tissues. Yeah, you can do connective tissue grafts, as we saw here, some colleagues were showing, also soft tissue substitutes. In my opinion, it doesn't really matter what you're using to increase your tissues vertically. The fact is that you really need to do that, and the fact is that that's important. Now, but let's stop a little bit here and think about, okay, is there any other way which I could use a tissue-level implant to increase vertical tissue thickness? So one of the ways it's been suggested and to just submerge the implant deeper. Place implant deeper below the bone, 2 millimeters, 1.5 millimeter, and that really increases tissue thickness. However, usually it is recommended to do it with a bone-level implant, with stable connection implant, not with a tissue-level implant. Here is really an interesting, let's say, aspect which needs to be discussed. Is it really possible to do with this kind of implant design? Maybe the design is different, and that allows us to place even a tissue-level implant below the bone. Because when I look at the traditional tissue-level implant with polished neck and flaring, let's say, neck design, which when you place it deep in the bone, really compresses the bone, I don't think that's a really good idea. But if we look at this implant, so it has narrow neck, okay? So that's one good option. Then it is important that it has anodized surface. Now, why is anodized surface important? To give you a comparison, here we have just a few months before published our paper, which we really compared bone-level implants with tissue-level implants. And we found that we have almost no bone loss around around implants restored with multi-unit abutments, as you see it here. However, interesting was that these multi-unit abutments, which were connected to subcrestally placed implants, were anodized. So it was not just polished surface as, let's say, traditional tissue-level implant has. It has different surface. So it's not really known how anodization affects the bone, but you can see here in X-rays. The implant is placed below the bone, so a multi-unit abutment, which is anodized, is connected, and you see there is not a single change in implant in bone level during all the treatment and 1-year follow-up. Therefore, I think that indeed this part is probably also important, that the treatment of the surface must play its role in the development of crestal bone stability. So, to summarize it, well, of course, we still have, unanswered questions, of course, here. When I place tissue-level implant in a thick tissues and I place it at the level of the bone, leaving the surface for tissues above the bone, then I'm really confident, because I think that then you really do not have any problems. The interesting part, of course, is here, then you place tissue-level implant below the bone. And I would not really recommend to do that with a traditional tissue-level implant with a flaring implant neck and polished surface. However, this kind of implant design, maybe it's different because it has anodization and different angulation and more narrow neck compared to traditional tissue-level implant. But of course, what have really won my interest here is, of course, how do these prosthetic concepts change when we talk about a matrix implant. Let's look at just two concepts which I think are the most important from prosthetic point of view. How do we deliver our restoration? Is it cemented or it's screw-retained? And of course, material. So what we can really talk about, that no abutments, no tie bases, no cement, is, I think, the first really step to crestal bone stability. And in my career as prosthodontist, because let's say for the first 10 years of my clinical practice, I was only restorative dentist, meaning I did not place implants. However, that really I started to do later. In that career, I had two big, let's say, improvements of my work. One of them was when in 2009, I switched from cemented restorations to screw-retained restorations. And I really did not go back and will never go back. And this is one of the cases which really convinced me to finally really do it. Because you can see here 10 years difference between delivery image and 10 years follow-up. And what is interesting with these cases is that for some years you really have no issues. So 2009, delivery of the restoration, 2013, no problem. Suddenly, 2019, you have perimplantitis. Now, you have to intervene. You have to do something, maybe graft, maybe clean, maybe polish the surface of the implant. Different choices do we have. However, of course, first of all, you identify the reason. And when I removed this restoration, I drilled through the palatal surface, and you can see particles of cement, which were sitting there for 10 years, causing no problem. Suddenly, at the 10th year, we have perimplantitis. So, of course, first big step into really eliminating any kind of biological problems is making a screw-retained restoration. And to finish up this case, you can see that after we removed that crown, really, I removed all cement remnants, I just repolished the crown and put it back. Look what's happening. Really, the bone has its capacity to remineralize. And we see it in different cases. When you remove the actual cause and cement remnants, or let's say lack of keratinized tissues in some cases, you can really have the grow back of the bone without any difficult treatment. Now, before, of course, we go to, I think, in my opinion, the biggest step ahead which has been taken, and I think everybody talked about it, everybody saw the technical test. Yeah, this is actually the power of innovation, that to use zirconia restorations directly to the implant without any tie base or metal interface. That was actually the drawback which held us backwards for many years. Well, so why this zirconia is so important? Here again, we must really it's not just enough to say use zirconia. No, we, in all understanding, we have our in-depth understanding of the materials we're using. Now, I'm sure you all know that the soft tissues can be divided into two big zones, plaque zone, and adherent zone. And but I always say, the picture is always worth 1,000 words. And here I'm going to show you a small video. Before doing that, I'm going to just explain what you're going to see here. So here you have implant which has been extracted because it did not integrate, and it was full arch restoration, and you see a multi-unit, titanium multi-unit connected to the implant. But when we refine the implant out, you see that the part of soft tissues, vertical soft tissues, is still adhering to the surface of the multi-unit abutment. Now, of course, as every researcher wants to see what will happen. So we unscrewed multi-unit abutment and we removed it. And do you see the difference in cleanness of the surfaces? Do you see the real mark between adherent zone and also plaque zone? So that's why actually we need vertical tissue thickness to have protection of our implant. That's also why the material is important, because from which material our abutment, or in this case, direct screw-retained restoration, is produced, really influences the height of the adhesion and the strength of the adhesion. Simply as it is important. The feature which zirconia has is that it can be polished really smoothly. It is the most smoothest material we can have. Not any other material can be equal. We tested Emax, titanium, we tested different ceramics. Only zirconia can really reach the level of the smoothness. And this is our protocol, which we follow already now for 10 years. We polish our zirconia smoothly to about 15 nanometers, and that really worked for us really well. Now, because sometimes you can even have, when you remove the ultra smooth zirconia restoration from the implant, you can really have adhesion. You can see the remnants of the tissues adhering to the surface of polyzirconia. But that is not the blood you see on the screen, that's the remnants of the tissues. While in the other materials, when you do not have adherence of the tissues to the material, you can find the plaque or remnants of the breakfast of the patient. So that is really the difference. I like this picture, which was sent from one of my colleagues. You can clearly see that the plaque goes around subgingival part and does not really adhere to the surface when you have ultra-polished zirconia. That's important. Now, of course, we can dive into the deep, let's say, understanding why ultra-smooth surfaces are important because of epithelium. Actually, epithelium is our most protective cell, the first barrier for the bacteria. That's why you need smooth surfaces. But let's maybe focus better on what clinical consequences polished zirconia has. So this is the first actually case which led my thinking into using more zirconia or unglazed zirconia below our tissues. 2009, I made cemented restoration, probably one of the last on the premolar, and you see part of the white line, that's the part of the abutment which was left exposed. After 1 year, it was gone. It means that the tissues really climbed up to close the zirconia. This is how it looks after another 10 years. Completely integrated, nothing really is going to happen to this restoration. What about here? I don't know if you will believe me, but there is no grafting here. I didn't do any grafting, and just 1 year follow-up. Case, a single crown from one of my clinical studies which we're running, and the super polished zirconia below the tissues, and you see the band of keratinized tissues organizing. I still do not have a clear explanation how to explain this, but we can see it in different scenarios, leading to the same conclusion, that the best material for our subgingival tissues is polished zirconia. And that's how here the invention which we are discussing now really blends into our discussion. So in 2017, this is my first paper which discusses that we don't need glaze below our tissues. So now it became a norm. Everybody's saying, we do not glaze. But why? Yeah, so this is actually the first reference when we really talked about why it's important. So to the final end of my short lecture, I took a liberty really to analyze how, in my opinion, the ideal screw-retained zirconia matrix restoration should look like. So you can see that, of course, milled zirconia, it is the connection part. Of course, you do not really touch it. Later, if you go up, zirconia should be polished. And of course, then for aesthetics or for occlusion, you can glaze zirconia or layer, or maybe even fuse Emax, doesn't matter. I mean, it also depends on your choice. Well, take-home messages. I think every lecture should end up with those. Positive tissue level shape, anodized surface, no cement, no tie bases, full polished zirconia. Those, I think, the features which really blend into zero bone loss concepts philosophy. Thank you very much. And I hope that next time we'll have even bigger meeting than here. Thank you.
Thank you, Thomas. Thank you so much. So I'm really looking forward when you will have more clinical cases and some more clinical experience, but it was really nice to see your lecture, to apply the zero bone loss concept. Also, I think very important, we get these questions so much. How shall I treat this crown, the surface, the last slide that you showed? I think this is just the most important one, to have a polished part and then the glazed part. That's very, very helpful. One question I have to you, using conventional tissue level implants, we know, that usually the bone goes back to the rough part. What do you expect with the matrix implant? Do you also expect the bone to remodel to the rough part, or do you expect it to stay with the pink machined anodized part?
That's the most important question, actually. Anodization is somehow really changes the reaction of the bone. Now, there is no much research in this area really you could cite or rely on, but from my experience, let's say with a different implant which has the anodized multi-unit abutment, and which I showed in the lecture,
I saw it.
Those were really, you see the bone was really stable without, let's say, just, a thin tissue layer between the abutment, the multi-unit abutment and the bone. So we could consider tissue level implant as the same tissue level abutment. So it's one piece, So probably the bone could really behave in a nice way, as you saw there as well.
Yeah, cool. I'm curious. We have an interesting case series ongoing, I think, and we will find out more for the future. Thank you so much for coming here, Thomas. It was a real pleasure to have you in Zurich.
Okay.
Thanks again for your TRI talk.
Yeah.